Welcome to myprojectbazaar.com. In our project title is Centralized and Distributed Protocol for Tracker-Based Dynamic File Management. Our main focus of this project is resource utilization should be reduced and then load of the tracker should be reduced. Here we go to see the abstract of our project. Abstract. Here we discuss about BitTorrent techniques. It supports a protocol for use in sharing files. The major focus in no number of peers or sharing the same file is called torrents. The number of peers sharing same file and using same tracker is called swamps. Here the problem is the more number of swamps are eat more resources in a network. It's avoided by we introduce the two protocols such as centralized and distributed protocol. Those protocols too we can manage the swamps in dynamically. Now we are going to see the data flow diagram of this project. The data flow diagram is used to explain how to develop this project, and also it gives some importance of the project. This is our data flow diagram. Here first peers should be formed or registered. Here more number of peers should be collected from the internet and then request is formed to server. If anyone user newly enter into the network, first of all those user get the tracker list and choose file for sharing. Then all the peers should be allocated for the particular swamps. Then calculate the weight of the each and every swamps. If swamps peers to calculate the one of the swamp is big and another one of the swamp is small. Here small number of swamps are measured into form the big swamp. This is used to help the resource utilization. Then we implement the two protocol, centralized and distributed protocols. Those protocols are used to dynamically split the each swamp, because if one of the swamp contains more number of peers means it's have only one tracker. The workload of the tracker is very low, so it should be avoided by we split the big swamp into small number of swamps and allocate the different trackers. It should be used to reduce the tracker overload. This way to develop this project. Now we are going to see the running procedure of this project. Before we are going to see the running procedure of this project, first of all we want to install some needed software to run this project. It is divided into two types. First one is front end and another one is back end. Here front end is act as the NetBeans. It's a tool for running the Java projects, and back end is RAM server. It is used to store the large information in temporary. It's act as a backend and it's used the SQL queries to run the project. First of all we view the in our tool. It's our tool NetBeans. Then go for project and choose dynamic swamp and run the frame1.java file. Here it is our initial frame. Here we first collect the peers in internet. This is our peers in, and we get the tracker list. It's a tracker and a file and content of the file, size of the file and the status of the particular file. Next we go for swarm specification. These peers are depending upon the file to allocate the separate swamp. Swamp 1, swamp 2, swamp 3, swamp 4, swamp 5, swamp 6, swamp 7, swamp 8. Then we click for next. Here we get the each swamp's details. It's a swamp 1, it's a swamp 7. Using this combo box to we get the all the swamps detail. Then click the next button. Then we calculate the PS in each swarm, total trackers, PS in swarms. It should be operated by combo box, and we find out the large swarms and the small swarms. These swarms, then click the next button here, choose the small swarms and remove the finished pairs. Then small swarms are merged into form the big swarms. This process to be easily optimize the resource utilization. Then we click the next button. Here we get the collections of swarms and order the swarms. Next we apply the CSM protocol on here. Here click the next button. Here MED algorithm 2 problem should be solved. Here total number of swarms, total number of small swarm, big swarms, and each swarm size should be get, and each swarm's pair, excess number of pairs should be calculated here. Then we click the next button. Then we perform the MED algorithm. Here one of the swarm is swarm 1, another one swarm is swarm 3. Swarm 1 is a large swarm, swarm 3 is a small swarm. Get the details, and here get the details and find the matching files. If it is match means we are split and merged here, and tracker should be assigned. In this process is followed by all other large and small swarms. Then we click the next button. Here we solve the load maintenance problem by we get the small swarms and click the next button. Here each small swarm size should be getter. Then tracker should be overload of tracker should be get here, and then we perform the high load swarm to split that swarm to small swarm to we reduce the workload of particular tracker. Yes, split and merge tracker should be allocated here. This is our final output of this project.